So this week's mailbag, I got a few more retro goodies. Hi, this video is sponsored by JLC PCB, who make all my PCBs. If you're looking for some professional, high quality and fast turnaround PCBs, then I highly recommend them. Their current offer is 10 PCBs for only $2, and for that price you also get 24-hour turnaround time. That's pretty good, so go and check them out. So this looks like another mailbag that's going to be done over several days, because I know I've got stuff that's coming in from various places. So this is the first package. These are a whole lot of LED strips that I ordered. So I ended up buying 2,400 LEDs, and these are RGB LEDs, so WS2812s, in a protective strip. I got so many LEDs because my annual Christmas tree game just seems to get bigger and bigger. So I need to really fire this up and see how they go. All 2,400 LEDs. I think these are going to be taking quite a number of amps to drive them. So one way of being able to control these LED strips is using a Raspberry Pi. You can also use a small MCU. There's plenty of drivers for ESP32, 8266, or the Atmel microchip, STM32. There's bucket loads of drivers. But because I'm a Golang fanboy now, I wanted to be able to write some software in Go and be able to control the WS2812 LED strip from that. So there's an excellent driver that you can get from GitHub, which will drive the WS2812 LED strips. It supports PWM, PCM and SPI, which is pretty good. But I'm using the SPI interface on the old Raspberry Pi. You've got to make a few adjustments, like changing the SPI default speed. So let's run some code and see what it looks like. So I wrote some quick and dirty Golang software, and you can control it quite reasonably well with Golang and a very low-end Raspberry Pi. So since I've got 1,200 LEDs, let's see if this little Raspberry Pi can actually drive 1,200 LEDs. It should be able to, but let's give it a whirl. Okay, you can see that's having just a little bit of trouble. By the time you get, of course, to the end of the chain, the signal quality is degraded a fair amount, and also the amount of current that's flowing out to those end LEDs is pretty poor. So if I actually disconnect one of them, looks like I've got 3 chains now, 3 chains, about 900 LEDs. That's pretty decent. By the time you get to the end chain, it's not as clear, but still quite visible. So a very low-end Raspberry Pi can actually keep up with 900 LEDs without any problem, which is nice. And it's drawing about 1.2 amps, which is pretty decent for 900 LEDs. I don't actually have them at full brightness, because really at full brightness on a Christmas tree they'll be pretty bright. So this is about 20% brightness, which I think is probably decent. So not only will I have this as part of my Christmas tree game, but also I have an upcoming video this weekend, which is all about how fast can you design, manufacture and build a PCB and put it up on Tindy for sale. So that includes designing it, laying out the PCB, sending it off for manufacture, getting the boards back, sourcing components, building boards in under a week. So this weekend's video is going to be fairly interesting. Whether it works or not, I don't know, but let's see. So on to the next thing. And then there's also this. Okay, so these are some portable lights that I ordered, and the reason for that is whenever I go out to meetups and things like that, I haven't really had decent lighting. If you watch the RC2014 meetup, that was sort of a bit dark, and I could have actually done with some decent lighting. Unfortunately, this doesn't, I don't think this one came with a battery pack, which is a bit of a bugger. So I'll have to make up my own battery pack here. Should be fairly straightforward. Let's see how bright it is. These are 12 volt lights, and I think it's center positive. Yes, always a good thing. I've limited my bench power supply to 500 milliamps just in case. And the good thing is you can actually change the color temperature. You can go to yellow, which isn't sort of yellow, it's more like white, and go up to sort of white. They'll be quite good as lighting for when I'm out and about, and I'll get the little battery pack, or I might just have to make my own up. I can 3D print the battery pack, that's no issue there. So my next meetup, I'll be definitely using these. So last weekend I published the C-Sky review, which I thought probably a little bit damning, but it's actually quite a nice little chip for what you get, but I still think it's a little bit too late in the game. Had they released this last year, then this would have been absolutely fantastic. The year before, then it would have been absolutely incredible. It's still a decent thing, but for what you get, if you want a cheap SBC, then don't get one. If you want to include this as part of one of your products, then yeah, it's pretty good. It's a pretty decent little chip. One of my subs was working on building a Gentoo release for that, so he sent me the image, and I'm just going to fire it up and see how that goes. Of course, it takes forever to boot, and really for a tiny processor like this, you'd really want to run a minimal Linux distro. It looks like there's no software I2C or SPI, and apart from that, everything seems to be a very similar build to mine, but of course using Gentoo as the Linux distro. There's not a heck of a lot of memory available on this tiny little sock, but you can kill off processors that you don't need and free up some memory. And since I'm a Golang fanboy now, I'm actually thinking of working on Golang support for the C-Sky. That's of course one of those projects that'll take a while, so it'll be a way off yet. Anyway, thanks Crazy Ape for that. There's a link in the description below, and also on the comment section of my C-Sky review if you want to get that Gentoo image that Crazy Ape built. Alright, excellent. Let's move on. So, I've got yet another package. Let's crack this open. Okay, so this, what is this? What is this? Okay, so we've got a dock. We've got the bit. Right, I think I know what this is. This is the Sipeed MAIX, or however you say it, I don't know how you say it, M-A-I-X, MAIX. So this is one of the products that was in an Indiegogo campaign in Weekly Roundup number 61. So it's a product really for artificial intelligence, neural networks and so forth. Based on the Kendryte K210, this is a module made by Sipeed. It breaks out all the good stuff from this Kendryte. So the K210 it's a dual core 400 MHz RISC-V chip. You have full control over voltage levels, so you can overclock it to 800 MHz, I think it is. It also has a neural network processor, or KPU, which provides object recognition at 60 frames per second at VGA resolutions. Audio processor, camera interface, parallel RGB interface. It's also got a field programmable array, which is unusual for a SoC. Most MCUs have that sort of capability these days. It's just a simple way of being able to map any of the plethora of functions within the SoC out to any of their GPIOs. It's called the CCOM interface on microchip, but it's unusual for a SoC to have it. Has hardware encryption engine, so it's really good if you're really into neural networks, object recognition. This is quite a nice little product. So I've had a bit of a look. There's a fair amount of documentation around, but no fancy onboarding guide, so this will require a bit more digging. So Zapan, sorry if I've pronounced your name wrong, he sent me these samples. I actually also backed the Sipeed as well, because I was quite interested in it for one of my little projects I've got in the back burner. I backed 5 of these modules, but Sipeed was kind enough to send me some review samples, so that's quite good. Thanks for that, Zapan. Let's get stuck into this and build it up. So there's a bodge Y here for some reason. I don't know why. I suspect that this may have been a prototype or something, but let's just fire it up without that connected and see what we get. Okay, so obviously it's been preloaded with something generating the image, but it's not really generating. I can see an image vaguely there, but there must be something funny going on. So I suspect that bodge Y there was, I don't know, maybe it's a horizontal sync or a vertical sync or something. So just looking at Zapan's message that he sent me, it is an alpha version, so of course it's going to be a little bit dodgy, but it's good to see that we're getting some response. Okay, so it must be a bit of a dodgy connection. I couldn't actually solder that on because it's always really hard to solder onto that sort of plastic, but you can see he's already preloaded it with a nice little app which will automatically detect faces. It's upside down, but that's fine. Okay, so this looks like a grounding loop problem. I think this Y here is an extra ground. Obviously I'm getting too much interference, and there's maybe the ground is floating. But you can see that if I look away, it can pick up a face pretty quickly. So that's good. Yeah, look at that. That's pretty quick. And it can handle it at 60 frames per second. So let's see how this one goes. So MaxPy. So I think he's got Python code running on this. So I might fire up the console and see what I can do with it. Now the only thing is, which way round do I mount the headers? Do I mount them this side or this side? I reckon I'll probably have them this side, since the screen is going to be facing out that way. I don't know. I'm sure I'm doing it around the wrong way, but hey, I've been known to do that in the past. So there you go. As I said before, I've probably put them around the wrong way, but I figured that might be easy to get to. Anyway, let's fire that up and run some Python code to see if we can get some sort of control over this. So if I add a jumper to pin 18 and ground and 18, that should theoretically drop into demo mode. So at the moment it's just displaying the output of the camera. I think I might have to get some Python code going on this. Okay, so removing the jumper and then pressing the reset button, which is that one here, we should see some response. There we go. We've already got the Python interpreter up and running, so let's chuck some code in. So I'm going to start up my noisy Keysight Crow. Sorry, DSO. Oh, I keep getting that wrong. So I think first of all I'll have a look at some PWM outputs and see how fast I can get the PWM going. Now, just looking at the examples from their website, I'm going to initiate a PWM on pin 12. There's a couple of instructions you have to do to create a PWM pulse. The first two commands essentially assign the PWM function to GPIO 12, and then the third one creating a 7 megahertz clock with 50% duty cycle on GPIO 12. So you can see that's a pretty decent signal that's coming out, 7 megahertz. I wonder if we can actually bump it up to something like 10 megahertz, 20 megahertz, maybe even 100 megahertz. I'll have to change my probe tip because this ground wire is just a little bit too long to be using for 100 megahertz. So let's try that. Okay, so this is a much better way of probing high frequency signals. Okay, so this is 20 megahertz, which is pretty nice. Nice clean signal. And now that I've moved over to 10 times probe, that's pretty good. Not a heck of a lot of ringing. Okay, let's go up to 40 megahertz. So this is 40 megahertz, which is yet another clean signal. I wonder if we can go up to 80 megahertz. And yep, that's still looking pretty good. I'm using my Keysight DSO and I haven't actually modded it up to go up to 200 megahertz. It's looking like a fairly decent 80 megahertz signal, so let's go up to 100. Okay, so of course it's instead of going to 100, it's gone to 160 megahertz because that'll be the next step up. And my DSO can't keep up with it, it's just showing nothing. Okay, so let's try one of the imaging Python scripts and see if we can get an image from this and display it in real time. So those commands just initialize the display and also the camera, and creates an image object that you can pull from the camera. So the next thing is we'll just loop around, continually fetching the camera and displaying it on the LCD. That's actually pretty good for an interpreted language. It's pretty much real time with a bit of lag, but that's okay. I also noticed in the onboarding documentation that there's a VI app module, which is really nice, so you can actually edit your Python scripts without having to use a computer really. All you need is a terminal, which is really nice. So I managed to get the audio hat, or whatever you call it, working with the M1. This is actually a pretty good demo. It shows you audio tracking, so if someone's voice is coming from a certain direction, it'll pick that up and highlight it. So it's actually a pretty good demo. So that's pretty good. Stop that. A pretty decent sort of demo of its capabilities. The Sipeed support has been fantastic. Jumped onto instant messaging and they've helped me out with some of the issues. It turns out there was a problem with this particular board, and it turns out there was a problem with the auto programming of this board, so it just sort of hung and didn't manage to program. That took a while to debug, but that's good. It all works really well. These are pretty cheap. They're not that expensive, especially considering this is $6 US from a Indiegogo campaign. That's really nice. I also backed the Indiegogo campaign for 5 of these, so I might give away a couple as well in a competition later on. Excellent. So thanks very much for that. On to the next thing. I've just gone to the post office and there's another package which I've been waiting for. So this just arrived in my post box and it came from Mr. Owen. And we all know who he is. This is something that I'll be using in my Christmas tree game. I got a bunch of modules. I got some input modules and some output modules, and of course a backplane. So let's solo this up. Now I've got to decide what I'm going to be doing. I can either mount these this way and have all 5 of them being used, or I can have one of these edge connectors here and have that for future expansion. I might just leave it as 5. I can always buy another board if I need to. So this is the digital input module. So this was the output module, and so the input module is very much the same as the output, except slightly different components. So I won't bother showing you how to build that because it's almost identical. So I think I'll use a bit of movie magic and convert this into a fully populated board. So there you go. That's pretty good. So I soldered the last row of headers along there because I was actually just running out of space a little bit to be able to connect everything up. So I think that's pretty good. I'll be able to connect everything up without any issues. So let's fire it up and see how it goes. Okay, so I've connected up an LED to one of the outputs and connected up one of the output modules into the input module. So I should be able to see that change. So at the moment the LED is glowing, so let's turn that off. So it looks like 0 on the output module is actually bit 8. If I set this one to high, then I should be able to read from that side. So the left hand side is the address and the right hand side is the value. So if I set this to high, then I should see it appear high on the other side. And there you go, Bob's your uncle. That's pretty good. So I'm all set for interfacing this with my other bits and pieces for the annual Christmas tree game. So of course I won't really be able to interface these directly to any WS2812s. Well, I can actually do it, but it would take a fair while to just munge through, and I need to actually write the software for the rest of it to be able to interface with everything else that I have running. So I'll probably just use this as a simple input-output for my Christmas tree game, with grunt work being done by a Raspberry Pi here and there. Anyway, so that's about it. I've exhausted the amount of things from my post box, and I think this might be the last mailbag before the end of the year. I'll have another weekly roundup next week, and then I'll run some Christmas tree coding videos, show you how I did it and what I did, and then you'll be able to have some fun playing the live Christmas tree game yet again this year. Anyway, thanks for watching and see you next week.